A microcontroller is a compact integrated circuit designed to govern a specific operation in an embedded system. A typical microcontroller includes a processor, memory input-output, and a peripherals on a single chip, sometimes referred to as embedded controller or microcontroller unit. Microcontrollers are found on vehicles, robots, office machines, medical devices, mobile radio transceivers, vending machines, and home appliances, among other devices. They are essential simple miniature personal computers designed to control small features of a larger component without a complex front-end operating system. How do microcontrollers work? A microcontroller is embedded inside of a system to control a singular function in a device. It does this by interpreting data it receives from its input-output peripherals using its central processor. The temporary information that the microcontroller receives is stored in its data memory, where the processor accesses it and uses instructions stored in its program memory to decipher and apply the incoming data. It then uses its input-output peripherals to communicate and enact the appropriate action. Microcontrollers are used in a wide array of systems and devices. Devices often utilize multiple microcontrollers that work together within a device to handle their respective tasks. For example, a car might have many microcontrollers that control various individual systems within, such as the anti-lock braking system, traction control, fuel injection, or suspension control. All the microcontrollers communicate with each other to inform the correct actions. Some might communicate with a more complex central computer within the car, and the others might only communicate with the other microcontrollers. They send and receive data using their input-output peripherals and process that data to perform their designated tasks. What are the components of a microcontroller? The core elements of a microcontroller are the processor, CPU. A processor can be thought of as the brain of the device. It processes and responds to various instructions that direct the microcontroller's function. This involves performing basic arithmetic, logic, and input-output operations. It also performs data transfer operations, which communicate commands to other components in the larger embedded system. Memory. A microcontroller's memory is used to store the data that the processor receives and uses to respond to the instruction that it's been programmed to carry out. A microcontroller has two main memory types. Program memory. Program memory, which stores long-term information about the instruction that the CPU carries out. Program memory is non-volatile memory, meaning it holds information over time without needing a power source. Data memory, which is required for temporary data storage while the instructions are being executed. Data memory is volatile, meaning that it holds its temporary and is only maintained if the device is connected to a power source. Input-output peripherals. The input and output devices are the interface for the processor to the outside world. The input ports receive information and send it to the processor in the form of a binary data. The processor receives that data and sends the necessary instruction to output devices that execute tasks external to the microcontroller. While the processor, memory, and input-output peripherals are the defining elements of the microprocessor, there are other elements that are frequently included. The term input-output peripherals itself simply refers to supporting components that interface with the memory and processor. There are many supporting components that can be classified as peripherals. having some manifestation of an input-output peripheral is elemental to a microprocessor, because they are the mechanism toward which the processor is applied. Other supporting elements of a microcontrollers include analog-to-dialogue converter, ADC. An analog-to-dialogue converter is a circuit that converts analog signals to the digital signals. It allows the processor at the center of the microcontroller to interface with external analog devices, such as sensors. Digital-to-analog converter, DAC. A DAC performs the inverse function of an analog-to-digital converter and allows the processor at the center of the microcontroller to communicate its outgoing signals to external analog components. System bus. The system bus is the connective wire that links all components of the microcontroller together. Serial bus. The serial bus is one example of an input-output port that allows the microcontroller to connect to external component. The distinction between microcontrollers and microprocessors has gotten less clear as chip density and complexity has become relatively cheap to manufacture, and microcontrollers have disintegrated more general computer types of functionality. On the whole, thought microcontrollers can be said to function usefully on their own, with a direct connection to sensors and actuators, where the microprocessors are designed to maximize compute power on the chip, with internal bus connection rather than direct input-output, to supporting hardware such as RAM and serial ports. Simply, coffee makers use microcontrollers, but desktop computers use microprocessors.